Agile webinar in the series of monthly webinars. Today's topic is adopting TDD. This topic is particularly relevant with the practitioners. Our observation is that while TDD is one of the most impactful of various Agile practices that we have seen, this is one of the toughest one in real world for development teams to actually adopt and adopt effectively. So I'm delighted to have a real practitioner and expert, Don McGreal, to talk us through and give us some guidance on adopting TDD. Don has 15 years of experience in software industry, and he's a passionate practitioner, consultant, and instructor of Agile methods, which makes him very good expert to cover this topic with us. He has been practicing as a consultant and has been playing multiple roles as a developer or a business analyst or a process coach. So he wears multiple hats and can see the practice of Agile from all those angles. And then as an instructor, he has run classes for thousands of software professionals around the globe. And he runs a website, tastycupcakes.com, which has a bunch of comprehensive list of tools for Agile adoption. So Don is a great person to have us learn from his experiences of how to adopt TDD. With that, I'm going to turn it over to Don, and Don will walk through present his session. That will take, in general, we'll take questions at the end, unless there's a particular question that really warrants to pick up right away, then I'll keep track of it and bring it up along the way. But towards the end, we'll take all the questions on this topic. So with that, Don, I'm going to make you the presenter so you can cover your topic. So now you have the control.
Okay, thanks, Hemant. So yeah, this is the presentation for applying unit testing and test-driven development. This is what's a little bit interesting with this is I don't get to bounce ideas off you guys, ask you questions as much as I would in a regular stand-up one. So I'm gonna try a little experiment. I'm gonna go through the steps. I'm gonna go back to where I first started using unit testing, or even before that, and I'm going to talk a little bit about the transition I went to. And in the next 45 minutes or so, the little short time we have together, I'm going to try to do my best to replicate the steps I've gone through on going from unit testing to test-driven development to behavior-driven development, and sort of the tips and tricks along the way. Now, not knowing who you guys are, I assume that there's probably some people out there that have been practicing TDD for years. Some may be doing unit testing but not getting the most out of them. Some may not have ever heard of TDD or BDD before. So hopefully what I'm going to do will apply to all of you. Those of you with a lot of experience may be able to apply this to your teams when you're going through your TDD adoption, or when you're going through the struggles you might have on your teams. Maybe you can take an approach like this too. Hopefully, one of the things I want you to get out of this is to realize that it's more than just writing tests, and the best way to actually learn this stuff is to go through it and feel it and use it as a part of your actual development practice. So with that, we're going to get started. Here you've got the plan. The goal is I'm going to start off with unit testing, talk a little bit about the basics of it. We'll do a little bit of an example, and then we'll jump into TDD. Again, another little demo. We'll talk a bit about what behavior-driven development is, which is getting a lot more traction these days, and another demo. And then the last step is more about other things you can do beyond what we talked about. We're probably not going to have a whole lot of time to cover all the pieces on that, but if I do, I'll probably briefly cover it. The rest of the slides will be available to you after the fact. So let's get started. Let's see here. So we're going to start with unit testing. Here is a quote that I assume many of you have heard before or even said. I know I've uttered this quite often in my career. I don't want to touch that. It'll take forever. I don't know what else will break if I do. Let me just rewrite it. This is a telling statement. It's a statement that we do hear a lot. I mean, I hear a lot with my clients. And it's one that's kind of reflecting something. It's reflecting a bit of, lack of confidence in the code you're about to touch. And I mean, anybody who's been developing for a while has had that feeling when working with code. Now, with the unit tests, having a good set of unit tests will get you around some of that feeling. That's kind of the goal with it. It's as QA and testers, their jobs are often to test the quality of the features and the functionality of an application. We as developers are mostly responsible for testing the quality of the code itself, and that's one of the great things that unit testing does. It provides sort of a harness, a safety net around the code that we have, and it acts like an alarm system the moment anything changes from a functionality standpoint. And we'd also, by creating these, it's going to create a big set of regression tests. So we were not going to be hopefully not reintroducing bugs that we've had in the past, as long as we've got these tests in place. Overall, it reduces the number of defects. It fixes the defects a lot quicker as well, because you're thinking about all the different things that these behaviors are doing in your code. And now the overall goal is to get that confidence back. That confidence to allow you to make the changes you want to make. In the bottom or in the right side there, you've got what we call a virtuous cycle, opposite of a vicious cycle. A virtuous cycle, what it does is you'll find that the more tests you have, the more confidence you'll have in the code. Meaning you can go in there and start ripping things apart and making changes, and as long as those tests aren't failing, you know you're not breaking a bunch of other stuff, a bunch of functionality. So by having that confidence, it gives you the ability to make those changes, rather than running by some code and seeing it and going, wow, that's ugly, but I don't have time to fix that right now. I don't want to break a bunch of stuff. I'm going to move on. By having those tests, that safety net in place, it allows you to make those changes. And the more you can make those changes, the more your team can actually go in and make those changes, and the better quality you're going to get out of your code base. And what you'll find is the better quality your code is, the easier it becomes to write tests against it. And you'll see then that creates this virtuous circle that spins up pretty quickly once you get it going. So the better quality, the more tests you have, and then away we go again. You can imagine how hard it might be to write a test against some code that is very poor quality. Imagine a method that has thousands of lines of code. What would the test look like against that particular method? So so that's kind of a warning sign. If you find it's hard to write a test against something, it's probably telling you something about the code you're trying to test. So that's unit testing. It's something that you have probably seen before. Maybe you've already even done it, but maybe you haven't used the same tools that we're going to be talking about here. Even before unit tests, if you're out there and you haven't written a unit test before, you've probably done something very similar. Think back to a time where you've built a bunch of code, and maybe you don't have an accessible UI or nothing really to make it to test it, or maybe your UI is just a bit harder to get up and running, or it doesn't have a UI at all. What types of things do you do before you check that code in and say it's done? Maybe create a main method, a little program that will run through it and test it, run your application of just the code that you just built, print it out to the console maybe, eyeball it. We do these things all the time anyways as developers. However, we do them all our own way. So we're not very consistent in the way we do it. Maybe the different people on your team do them a little bit differently. They're not always automated too. What you're doing back in those days, and I'm going back to the way I was before I even did any unit testing, I do these little scrapbook type applications all the time where I'd write them, I'd make sure my code's working right, and there's nothing really to, I'd eyeball it, and I might miss something. I'm looking at what it prints out to the console, and so I could miss something because of the lack of automation there. It's not shared either. Those aren't things that, if I built a little main method, it's not something I'm going to check in. It's not something that other people on my team are probably going to run. It's these other little ad hoc tests that I do to make sure I've accomplished everything I wanted to. And really, it's not as easy as it could be. If you think about it, building up a main method, writing out some applications, thinking up interesting ways to test what you just wrote, it's not as easy as it could be. Maybe it's a little UI you build, a little scrapbook thing that pops up, and you got to build a little, if you're in Java, a little bit of Swing application or a Windows form or something like that. It's not as easy as it could be. So we are going to look at unit testing and some of the tools around that as well. So with unit testing, if you just break it down, and we'll look at the words themselves. The unit is described as the smallest testable part of an application. What this means is, if you think about it, I'm sure some of you are thinking about it right now, and the smallest testable part of an application may be the method, a method on an actual class. That's what you would actually call from somebody on the outside looking in. They don't really know what's going on between it. And then after that method is run, it changes some state, it returns some value that we can then check afterwards. So that's kind of the smallest testable part of an application. And the test itself, a test, if you think of that word, it's a test of something that currently exists. If I write a test, I'm testing my existing knowledge, or if I'm writing like a test in school. So the term unit testing implies that we're testing methods on existing code. And that's kind of where we started out. And in my career, that's where I started out, where I would look at a class, and I would look at a method in that class, and I would look at everything that method does and write a test for it. So for every path in that method, I would have a separate test. And I would have, for every class, I would try to have the discipline to write a test class for it. And for every method, I'd have at least one test method. I'd have several depending on what that method does. Each test then I would break up into 4 pieces. You've got setup, exercise, verification, and the teardown piece. The setup is what we need to do in order to actually run our test. The exercise is running the actual behavior, and then the verification is an assertion that it's doing what we want it to do. So this is a tool that we can use. This example is with, I guess it's MS Test for C#, but you've got JUnit and others that are out there for you. It's just as easy, if not easier, than the types of tests you would do without a tool, and writing up a main method to do this stuff. And you've got assertions that are built into the framework that'll automate it for you rather than having to eyeball things. So it'll actually tell you they can run, other people can use these and share them and add to them and build up on them. So that's kind of the idea. You've got a list of assertions that you can use as well. Teardown is meant to, if you've left your system in an invalid state, you can use that, take advantage of the teardown feature or area to clean up any messes. So that's the idea of unit testing. The best way to do this is to actually try it. So what I'm going to do is I've got a very simple example, one that we can actually do in the time we have. So I'm going to jump out of here and jump into Eclipse here, and I've got something already set up. I've got a simple class called person, and in this class it has a first name, last name, middle name, and a gender. When we create it, all that stuff gets passed in. A last name is the only required field right now, and over here you've got a get full name method that does several things. So what we want to be able to do is to test this class. I've got a class, let's say we just wrote it, we're pretty close to it, we kind of understand our logic and we built this up. So, but I want to write a unit test for all the reasons we've discussed. I want to have a good regression test, so I want to build a unit test for this. So in this particular tool, you can just go in and from the class you want to actually test and select it to build a new unit test, a JUnit test case. Within here, it's got the person. It's even going to suggest naming it person test for this particular class. If you hit next, you can even go in and select what pieces you want to test. So if I'm expected to write at least a test for a method, I would go, all right, here's the constructor. Here is the get full name method that does all the work. I'm going to ignore the getters for now and bring them in. And so this is what it would start me off with my test. So it puts in it makes all the tests fail at first, but I can get rid of those for now. And let's just focus on this get full name piece. We said it was broken into several pieces so that we've got a setup that we have to do. We've got a verification that we have to do, and then an assertion that we want to do. I'm sorry, the verification is the assertion. What we're missing here is the execution that we want to try. So a setup for this class would probably be just creating the class itself. So let's create a person class. Person equals new person. It does take a bunch of stuff, first name, last name, middle name, so I'll throw mine in there. It's Don McGreal, and my middle name is Thomas, and this is an enum here, I am a male. So there's the setup. Now the actual execution, since I'm testing the getFullName method here, is to just simply call full name, which will return a string. So I'm going to say full name equals person dot get, not get first name, but get full name. And now the verification that I want to be able to do here is I want to assert that the value full name is equal to something very specific. So I want it to actually say, if you looked at the code, Mr. Don Thomas McGreal. So the expected is the first parameter I'm going to put in here, Mr. Don Thomas McGreal. And actual, I'll replace this with the variable for full name. There's my first test. And if I were to run this, I can just go up here and say run as JUnit test, and it should tell me whether this passes. And it should. This is behaving as I expected. Mr. Don Thomas McGreal, given that, and given that I'm a male, it's going to say Mr. This is what I'd expect back. I always get a little bit nervous when it passes for the first time. It makes me think maybe it's not actually running the test. So a little trick is to, make it fail somehow, just to make sure that you're not crazy. And there it is. It's red. I'm going to make it pass one more time here. You'll notice down here's a plugin for Eclipse if you are interested. It's called Infinitest. It runs my tests all the time. It's continuous testing, but that would be for another presentation, I'd imagine. So there's my first test. Looking at my person class, I want to be able to test all the different paths through here. That's a good trick, is if you're looking at this and I want to test all the different ways, I see one path. There's probably, if you think about it, one way down here if he's male, that was the one I took, and I skipped this piece and did the rest. There's another one if it's female, and probably yet another one if none of these pass, because there's not an else in here. So there's 3 different things I can do to this particular method. So let's go for the other one, female, which is the second path in here. So what I'm going to do is in my tests, I'm going to create another one here. So I'm just going to copy what I did. But up here, this is get full name for a male, but down here, I want get full name for female. And to make a little bit of a difference here, I'm going to change this. When I create a person, I'm going to make another person. Let's say it's about Donella, and who is female. There we go. And then down here, I can change my expectation. So this should be Donella, who is a Mrs., like that. Wait, all right, run my test again, and whoa, I'm failing. If you look at this failure here, you'll notice that down here in your unit test, it's going to actually tell you what the difference is. And I'm going to see if I can zoom in here. Don't know if that's going to do it for you guys. But you can see where it says misses, and there, it looks like I'm missing a space here. So what I'm expecting back is wrong. What I've actually done here is I've discovered a bug. I have a failing test that's showing that I'm missing a little bit of a space in here. So that's going to have me go back to my full name method to see what's going on here. And what I notice is that this here, I did not put a space in. But as soon as I do that, and I've got this failing test behind the scenes, and if I were to do that and run it, I would go back to green. Now, I did that on purpose. I wanted to get you to have that kind of feeling of having a failed test, but having something very specific to do after that. I have something that's failed. I discovered a bug, but I knew exactly what I had to do. I had to go in and just work on it until this test passed. So it was a very specific thing that I had to do. That is something that we're going to get into with TDD is, well, if I were able to do that with bugs, if I can go in and find a bug, why not just write tests that fail to begin with, so that I can have a specific task to go after after the fact. So just put that in your back pocket for now, and we'll come back to it. So you'll see now we've got 2 different tests. I'm able here to just write them any way I want. If you were to look at my person class, I also did one for the constructor, and if you look at this, there's two different paths in it. One is I'm throwing an illegal argument exception if last name is null. So if I were to go back into person test and do something for that, up here I've got test person. I'll probably call this no last name. And for the test here now, I basically want to create a person, and I want to reproduce that. I want to actually test that exception isn't there. So that exception is actually thrown if I do not pass in a last name. So I'm going to put in null here. Just to see if I can actually make that test pass. So with a unit test, how could I possibly make that other test pass, or how do I test for an exception? Well, there are several ways of doing that. Writing code here, you can put in a try-catch and make sure it follows the right path. But most unit testing tools, frameworks give you an option of extra parameters where you can put in. And with this JUnit, you've got the expected exception one, where I could just say expected equals and then the name of the exception that I expect, or the actual class of the exception. By doing this, it should run and it should pass that test here as well. If I look down here, I've got all three of my tests passing. Again, that passed on the first one, so I want to make sure it doesn't pass if I actually passed in a method or an actual last name. So yeah, there, it doesn't work. And I'll go back to my my little null thing here. So there's a good little example of exceptional flows as well. So there we go. And with unit testing, you'd be looking at the classes you just built. You're going to be looking at the pass through them and then adding on to it from there. Now, I've always found when I first started doing unit tests, there was this sense of redundancy every time I did it. I went through, I spent maybe hours and hours working on a problem. I make it work, very intimate with that problem, and then I'm expected to go back and write a test that just tests the stuff I just spent hours thinking about. And it felt redundant, but you know, I wanted to be disciplined about it. I knew there were other benefits of it, you know, as far as regression tests and building up that safety net and the test harness for future development. But it was something that always felt hard, and it was, you know, when push came to shove, it was the type of thing I would just drop as well when the deadlines were coming up. It was a nice to have. It's kind of the approach I had a lot to this style of testing, where I knew all this already. I just spent hours working on it and was intimate with the problem, and now I'm just writing tests that I know are going to pass. So there was always that sense of feeling where, I don't think I ever got the code coverage that I should have with my tests because of that. So that brings us into kind of the next style here, which is test-driven development. With TDD, we're going to do this a little bit different. Think back to when I created that error for when I was adding the female person. I was able to write something and check it against some value, but it didn't work. The actual functionality was not there that I wanted. But I had a failing test, and my goal was clear: make that test go green. And it gave me a sense of purpose. So I remember when I first started doing this, I was on a project in 2004 down in Houston, Texas, and I was going through writing unit tests when I could. I had 20, 30% code coverage. I was trying to be disciplined about it. You know, it was probably the most on the team doing unit tests. And I realized one day we had a production problem, and it was kind of everybody stop, everybody panic, you know, stop what you're doing, everybody work on this production problem. And we got some reproduction tests. We had the test data that we had to use, and with this particular system, it would take, you know, 17 minutes to redeploy an application and build it, you know, even locally, so we could start testing on the same version as what was in production. So, and then it would take more time after that to go to the exact spot and start trying to reproduce the bug. And I remember this one particular instance where I had some unit tests, and this bug came in, and I'm like, I kind of have a feeling where this could be. And I went into one of my unit tests, and that were it was already in that there, testing something similar, and I copy-pasted and made another test and changed it to the values that were given to us from production, from the bug. And I was able to reproduce the error right then and there. And that kind of was a trigger in my mind where here I am writing a test, and it haven't, I've reproduced a bug, and by the time I reproduced that bug, the first person hadn't even deployed the app yet to start testing. And here I was, I just reproduced the bug in a matter of, minutes. So what I was able to do then, my goal was clear. Or I was able to go in and make the changes, update it, and make that test pass. I did whatever I could to make that test pass, and I did. And I didn't break any of my other tests. And by the time I actually solved it, still the first person hadn't even started trying to reproduce this bug, doing it the old way, which is, going on the UI and banging away at it. So I actually solved it, and just to, before checking in and saying I solved it, I guess I did have to run it up or run up the whole application and make sure I did solve the bug before checking in. But that sort of switched. I thought to myself, what if I don't just do that for bugs? What if I do that for any new feature coming in? Treat them all like that. I'll just write the test and then go make it pass. So that's what TDD is. It's, you start with the test, and if it doesn't pass, it's a good thing. That's your goal. You're happy about it. Now you just start writing code and following this path and keep going until that test passes. Good. Check it in because you've done something, and then move on. Write the next test from there. So for every new, not just for bugs, but for any new features, for whatever comes in, you can start it with a test. So the idea is to do test, code, and then design, then kind of refactor it. The first thing we want to do is let's get that functionality up and running. Then let's worry about fixing up the design, making it look pretty as well. That's the TDD mantra of red, green, refactor. Red, test, write a test and make it fail. Green, make the test pass, and then let's refactor it after that. There's also this think version, and if we go through some of these, this is from James Shore, wrote about this in a blog years ago, which this is the most important step, is to think. Take as long as you need for this. And I mentioned it earlier, when struggling with a problem for hours and hours and becoming intimate with it, it kind of felt redundant to write a test afterwards. I was just making kind of a mindless test, and I was probably even swayed a little bit because I wasn't thinking maybe about what it should do. I'm thinking about what I just wrote it to do. If you do this piece, you're thinking about your API. You're thinking about how people are going to use what you're about to write. You're thinking about the best practices and you're actually designing at this point. And a lot of work goes into this part of how would I want to use this piece, this component that I'm about to build. So that's an important start. Once you've got that figured out, you're moving on to a test. Let's write a test. Let's get it stubbed out so it at least compiles, but the test fails. And it gives us something very specific then to focus on. Then the next piece is the making the test pass. Now this is an interesting part where all we want to do is make it pass, do whatever we can to make this test pass. If we're able to make the test pass with just some kind of dumb hard-coded value, returning that, all that's doing is it's telling us that our tests aren't good enough, and it should encourage us to write another test or a better test. So this is really that. Write a test and just do the dumbest thing you can think of to make that test pass. And if you can make that test pass, then you've got that piece of functionality working. Now, then there's also the next piece, which is the refactoring piece. We still want to hold true to our design principles and building it so it's a nice maintained system. That's where the refactoring comes in. The best example or analogy for refactoring is the kitchen one, where if you think to the last time you maybe had a bunch of people coming over for dinner, or you're having a bit of a party, and maybe you and your spouse were in the kitchen going crazy, getting last-minute preparations, and you're cooking and you're putting the stuff together. In my house, it's usually my wife, when we're going through, she gets mad at me when I start cleaning stuff, and in between cleaning or using a pan, I'll clean it, or I'll put stuff in the dishwasher and stuff like that. And she'll get mad. She'll be like, no, don't worry about it. Let's just get this stuff done, and we'll figure it out at the end of the night. Like, we got people coming over. Stop messing around. And I usually would give in, and we'll go that way and have a great time. And then at the end of the night, after maybe a few glasses of wine, you look at that mess, and your typical reaction is, you guys have probably been in this situation and know that often you're just like, let's just leave it till the morning. And maybe you get to it the next day. Maybe you might leave it for another few days, or maybe the next weekend when you have some time and the smell isn't too bad. You actually go and start cleaning the stuff up. Now that might work fine in your home. You know, it's a bit of a mess afterwards, but it might work fine in a home. But what if the next day you had another crew in there, somebody else using that kitchen, somebody else working in it? What if it was more of a professional environment? What if it was an environment, you know, like a restaurant, an actual kitchen where there's no way you should leave stuff over for the next crew? And if that was what everybody did, that would build and build and build and build this debt of mess in the kitchen that would, you know, at a certain point you just have to stop everything and clean and not actually be productive. Any professional restaurant has a very clear system that you clean as you go and you never leave a mess for anyone else, any other crew. And that's what we're looking at with the refactoring step. It's about going in and leaving a nice, clean area for the next person in. And you have to think about the type of what type of work you're doing right now. Is it equivalent to your home? Is it a small application that only you and maybe a couple other people are going to be working in from time to time? Or is this an environment where lots of people, hundreds of people, are going to be working in the same code base as you? And then think about what responsibilities you have to them. That's the refactoring piece, and that's a whole other topic of its own as well. But this is the part where you would do that, where after you do red, green, and then once you got the test passing, you have the ability to go in and do the right thing and clean it up as much as possible. And the nice thing is you can hack away at that and fix it because you've got that green piece already done. Your test is there. You're already testing your functionality. So there's not a whole lot more you need to do. You don't have to worry too much. You've got that confidence to make those refactoring changes. And your test will tell you if you did break something along the way. So that's the TDD mantra. We want it to be quick. You know, the more you get into this, we're talking about little steps. This isn't about write a test and then, you know, write a set of tests and then spend the next few days making them pass. This is write a very simple test. Something very simple. Check one little thing, one assertion, and then make that go. Check it in and go on to the next piece. So it becomes much more rapid, your feedback cycle becomes a lot quicker, and your communication within the teams do as well. So that's the TDD piece. The nice thing about it is because if you've ever heard of Yagni before, it's you ain't gonna need it. You're only going to be writing code to fix a failing test. So the moment you're in code and everybody's experienced this, you're writing away and you realize that, hey, we haven't really figured out what this one requirement is yet. And you go and start asking questions and somebody gives you an answer. You're not going to go write the actual application in yet. You're not going to build that into the application. The next thing to do is let's build a test around it. I'm not going to write any code unless I have test first. So that allows us not to make assumptions. We're just got a clear goal of making that test pass. We first have to agree on what that test looks like. But we're going to make that test pass. A case study here, I'm not going to get too much into this, but if you want to, you can, there's a URL on here, an InfoQ article that goes to this company or this organization, Empirical Studies, that this is the first large-scale TDD test. They did 4 projects at Microsoft and IBM that used TDD against 4 that did not. And they found as the defect density decreased by 40 to 90%. And there are other studies that are similar to this. This particular one increased the development time did go up a bit, but they did make a point that, and everyone on the team agreed that it was offset by the reduced maintenance. They actually built more stuff, which is why it could take more time because they didn't actually leave the holes for bugs. But there's more information on that. It's a good article to read. So that's TDD. Let's again, you know, rather than rambling on about this, why don't we just try something? So I'm gonna hop back into Eclipse here, and now rather than write a test against something I already have, let's write something for a new feature. So I'm going to write a test, but this time I'm going to worry about what if somebody does not give me their gender. And so I'm going to test the same method, get full name, but this is going to be an unknown gender, which I'm going to allow in this particular app. So I'm just going to do a little bit of copy and paste here. Now this time, I've created a new person, but this is going to be I don't know the person. Maybe we'll do this as a Pat right here, Pat McGreal. Okay. I got an uncle named Pat. And so this is Pat, could be male, could be female, I'm not sure. And then in here, I can say unknown. Now notice there is no unknown gender. But in test-driven development, I'm going to go in here and I'm going to write it against the API that I want, not what I have. So I'm going to go in here and say, you know what, I want them to be able to pass in an unknown gender at this point. And that's the way I want it. It doesn't exist yet, so it's going to stay red. but that's fine. And then in here, when I say get full name for this one, I'm probably, I get to decide what this looks like here. So here I am thinking about, if it's what is the requirement if they're unknown? Do I say Mr., Mrs.? Maybe I do a Mr. or Mrs., something like that, or a dash, or maybe I don't put anything in there. But I get to decide at this point. I'm going to save this. I still have a compile error here. So as the writer of the test, I'm at least responsible for stubbing this stuff out. So in here, you'll see that Eclipse is nice enough to give me some suggestions. It says, would you like to create another constant known as unknown in the gender enum? I'm going to say yes. And there it's added. So the nice thing is these tools these days make this a lot easier for us to write against a non-existent API. And so this is how I code now. I always code to what I want and then lean on the tool a little bit to actually generate everything. So I create a person, I get the full name back. So at this point, I'm at, it compiles, ignore this little thing, this is part of Infinitas. This is just telling me that that runtime test is failing. But I should still be able to run my tests here, but this should fail. I'm now at the red start of the red part of the red-green refactor. So it's unknown, does not work. It tells me why here. It says Mr. and Mrs. was expected, but was Pat. Oh, one thing I realized here, I should have made this. Pat, run the test. And it says, yeah, it was expected, Mr. and Mrs., but I just got back, blank, Pat, Thomas McGreal. So now I've got a failing test, but I've got a very clear goal. I'm going to keep going now until I actually make this work. So I'm in this full name thing. The simplest thing that could actually make this pass, let's see, maybe I'll do an else, like that. And in this else, I'll say, I guess I don't even have to say an if. I'm just going to keep going until I make this pass and I haven't broken anything else. So just maybe a full name plus equals and actually put in what I wanted back there, which was Mr. Or Mrs., I think is what I said. Now, I may have forgotten, I may not know, I may not have done this right, but I've got this test here, and I can just keep running, and it'll tell me when it's fixed. So down here, I'm like, oh, wow, I thought I made that work, but if you look down here, it says Mr. or Mrs., space, Pat, and over here, what I'm actually getting is without the space. Oh, right, so I missed my space. And I get to keep going and working on this until the bar goes green, and I'm good, and I haven't broken any of my other tests, too. In doing so. So I've made that particular test pass. Now you'll notice some of you may be looking at this and going, wow, that's kind of ugly. I don't like all those if statements. It kind of feels a little bit like type checking, who knows. And who decides on Mr. and Mrs., maybe it shouldn't be the person. Maybe it should be the actual gender. So that's more of an OO thing. But what I'm looking at now is kind of the refactoring piece. What are some things to make this cleaner looking than it is? I'm not liking all this kind of nastiness. So since I have all my testing, my tests passing, I have the confidence to go and start making these things change. If I can make this look better, I'm going to want to do that, and I'm not going to break any of the tests that I have passing right now. So maybe something quick I could do here and this is the refactoring piece. I'm going to give these guys the responsibility of knowing who they are, or what that actual of what the prefix should be. So I'm going to do this, Mrs., and unknown would be Mr. or Mrs. space. And what I'm doing here is I'm just saying this is an enum that's going to have a constructor, now gender, that takes in a string for prefix. And I'm just going to set this dot. Again, I'm doing this kind of a write first and fix it later. This dot prefix equals the prefix passed in. Fail it. Eclipse is going to complain yet, but it'll be nice enough to say, hey, why don't we create a field for that? And I'm going to make a getter for it too. I just type in get prefix. There we go. So if I do it this way, now in my little refactoring piece, I can go back to person here, and I can rip all this stuff out. and do it, and you'll notice my test is failing down here in the meantime, but I know I'm going to keep going until I get it back to passing. So full name is now plus equal, and I'm just going to go off to my gender now and give it the responsibility of giving me the prefix. And this is a refactoring that I have a backup of all my tests to make sure that they're still passing. So that's the refactoring part of TDD. And I haven't broken anything. And I've had the confidence to go in, rip it apart, experiment. I can always go back, but it's TDD. So that's where we are with the test-driven development. So it's about doing the same thing we did with unit testing, but doing it first, the whole red-green refactor piece. Nowadays, we talk a little bit more about BDD, behavior-driven. I'm going to talk. Let's explore a little bit of the differences here. With traditional unit testing, this is the same slide as we had earlier. We had a method per class. When I first started getting into test-driven development, after that whole experience down in that project I was on, where writing the bug and then fixing it, I still felt kind of weird. I felt like I still had to write a test for every method that was out there. And the other thing that was kind of awkward was if I had good code test coverage on like a ton of classes, on every class, let's say, and I decide just from a refactoring standpoint to completely redo something. Rename all these classes, maybe throw in like maybe I'm applying like a state pattern or something like that that involves interfaces and a bunch of other implementations. And my tests would keep breaking, and it became a pain to go in and do this, what we call shotgun surgery across all my application, a bunch of find and replaces to update them. And that was kind of annoying. And honestly, it throws a lot of people off of test-driven development and just having lots of unit tests, is that how fragile they are. BDD is a little bit different. It's like, what if we didn't worry so much about what classes we had and what the methods were and what their names were? What if instead we worried just about the behaviors we're trying to do, the functionality we're trying to actually create here? One step in doing that is to stay away from that whole style of test class and then test this method, test method, test method. And it comes down to a renaming thing, but it's more of a frame of mind. If I were to instead say, when my system is in a particular state, and if I start just saying it should do this and it should do that, rather than worry about all the methods on the test, and if I have a test coverage tool, I can tell if I'm getting all my methods covered. So I may have a method like 2 or 3 classes down from some functionality that I'm calling. As long as that's getting called and as long as we're getting the behavior we expect from where we are, then I'm not going to worry about it. And then that'll allow me to change those types of designs and refactor it all I want without having to change my tests. So it makes them a little bit more flexible, less fragile, and I get to focus on what the system does rather than what the actual names of the classes and stuff are. So that's BDD, where you actually can rename it. You make a little bit more of there's a setup piece you can do that runs before every test that we can take advantage of. And it becomes less about the test. This goes back to the initial description I gave of unit testing. Units were about the methods. Let's forget about that. And in the test, nothing exists yet. So technically, it's not really a test, is it? With BDD, it becomes more about a spec. You're putting up the scaffolding. You're speccing it out. You're writing out. You're building this initial piece of it. You're speccing out your design before you actually build it. It's too easy to come up with reasons not to test. I mentioned that earlier, where when I'm under the gun, writing a test on something I'm pretty sure already works feels very redundant, and it's the type of thing I might drop out if I don't have time. But specs become an integral part of development. If I start specking out what I'm about to build, it's no longer about a test at that point. It's about this is my scaffolding, and then I'm going to go build it from the inside out from there. And I'm no longer worried about units, which we've defined as methods before. I'm thinking more about behaviors. I'm going to worry more about how a developer will interact with the code, or what type of value we're getting back from the overall application, rather than what methods and what classes I have. So that's the essence of BDD. There are lots of frameworks out there that help you, but you can do the same things with your standard ones, JUnit, NUnit. Here are some that you can look at. So if we were to jump out to do another, I'm going to do a little time check here. So yeah, I got a little bit of time. If we were to do one last example for BDD, in this case, I would write a test. Oh, by the way, I put the test in the wrong spot there. I'm going to put it over here. I have a test class here. So now I'm going to run another test. This time, I want to test. I'm going to write a JUnit test case. I'm going to write a new test here. And I want to write a test against my person to test for initials now. Or actually not even just initials. I want to test that. What if somebody, the state of, or the situation where somebody doesn't provide me with a middle name, and I want to be able to test that particular instance. So when person has no middle name is how I would actually write my test in this case. And I'm not writing it against any class, so the tools don't really allow for that by default. So when person has no middle name, the type of test I would write is, I'm going to do the annotation here, or yeah, test would be public void, and then using that convention, it would start with the word should. When person has no middle name, should allow or should provide full name, right? Would be one, and I could do another one maybe for should provide initials. One of the things though is in here I just want to make the test, and I'm going to do all my setups in a separate area here. So I'm going to do a setup. Oh, it's not set up as before. And the test, the name of the method could be anything, but I usually just call it setup from old school. So if I have a setup method, this is going to get called before any other test I have in here. So the setup is actually, maybe I have a person here that I'm going to make available to anyone here. Person. All my tests are going to have that. And in here I create it. Person equals new person. And I'll put in Don McGreal, but no middle name. And then gender is male. And in here, I'm going to write a test just off of that. I'm going to jump right into an assertion now. So I'm just going to say asserts equal, and I'm just going to say this should now be Mr. Don McGrail with just one space in there. And that's what the person's full name should be. Get full name. Like that. So you'll see that this is a little bit different. I can do it this way. I can write for ones I don't have yet. Maybe I'm going to say should provide initials. This might be something I don't even have yet for initials. And you'll see that I set up a state, and then I test all the different pieces from it afterwards. And it's a particular, this is the BDD style. I'm not worried about the methods or anything like that. So this is failing if I were to do a quick run here. It fails, obviously. Well, I don't know why. Why does it fail? Because it's saying the word null in here. So I would probably have to go into get full name and take a look at the, under get full name here, this whole middle name piece, I probably only want to do if middle name is not equal to null, is when I would do this, like that. Now I'm just going to keep going and running it, and I've made it pass. The other one shouldn't have passed, but I haven't changed this. This would be get initials. Do that one. But I haven't built that, but we'd go the same TDD route. I would generate that and then keep going until this actually provided me with, DM, which wouldn't be DTM because this is the when it has no middle name one. And I could just, now my goal is clear, I could just go and make that pass. So that's kind of the idea of behavior-driven development now. It's more about the state and not about the classes and the methods and stuff like that. If I were to do the other ones, it would probably be, when a male person or a female person, I'd have different tests for that. So that's BDD. I'm going to leave you with a little bit on getting most from your tests here, where one of the things you're going to realize is the more tests you write, some problems arise. It's like if you want to do it this style where you're constantly every 2 to 10 minutes, I want you to write a test and run all the other tests so it doesn't actually break any existing functionality. But you're going to have to keep those tests fast, and you can't afford them being slow and taking forever. And one of the popular things that happens out there, or common thing that we see a lot of clients struggle with, are slow tests, because a lot of them are depending on external things like remote applications or databases. So those are fine to test, but they should be probably stored in a different area. And maybe we call these integration tests. What that does is you can separate your unit tests, which are completely in your memory, and they need to be, unit tests have to be run exactly the same every time. They have to be predictable, they have to be fast, they have to be autonomous, they don't have to be dependent on previous tests being run. And if they don't follow those three things, then they're not considered unit tests. Integration tests are good, but you don't need to run them as often. Though if you're working on the areas here that go out to the database or to any other applications, then you can write your test. But maybe if you're doing a continuous integration, they may not have to run every time you check it. Maybe at once a day or something like that. If you're working on it, you're probably going to want to test it more. But this way of mocking them out and stubbing them out, and that's where this whole dependency inversion principle comes in. For every remote application, you may end up with like a fake version that you can use for your tests. These are known as test doubles. If you want to know more, there's this book, XUnit Test Patterns, or you can go to the website. It's got all that information on it. I think it's XUnitPatterns.com. There's versions that are called dummies, stubs, fakes, and mocks, although most people just call them all mocks these days. And there are tools out there to help you with them as well. In this presentation, I said at the beginning we probably wouldn't have time to go through all this stuff. But if you have access to this presentation afterwards, there are some examples of dummies, stubs, fakes, mocks as well, some simple examples that you can do. With that, I think we're right about time there. So that was it. Hopefully you got enough out of this. It was we went through unit testing, TDD, BDD, a little bit about integration tests and speeding up your tests as well. We're going to have time for questions. I think Command's going to gather those questions here. But I'd like to thank you for coming out and listening if you're still out there. And I hope you got what you wanted out of this, and good luck with your TDD adoption. My information is on the screen here. If you have any questions with this stuff, or if you want any help with this is what we do all the time. Is we help with anything Agile. We're there, and we do stuff with it, improving enterprises. That's my Twitter, that's my LinkedIn, and my email address. Feel free to contact me. And with that, I will hand it back to you, Hemant.
Great. Thank you, Don, for the excellent illustration of the unit testing, TDD, and BDD. So with that, folks, we are on to our last phase of the webinar today, which is your Q&A. So I have some questions already, but if you can, and I'm going to bring up my slides here, if you can reflect upon what Don just went through, and if you have any questions, so we have more questions that we can pick from, just start putting your questions in the Q&A panel on the GoToWebinar. While you're doing that, I'll just take a few minutes and introduce SynerZip to you for those of you who have not worked with us or are not familiar with who we are. So keep please putting your questions, and in the meantime, let me just a quick intro to SynerZip, which is SynerZip in a nutshell. So we are a software development partner. We focus on working with small to mid-sized, typically venture portfolio type companies, and our real value is our teams work as an extension of the client's team and doing product development work for them following Agile techniques. For every client, we have a dedicated team which is doing the work as an extension of their local team, but we are much more than a staff augmentation type company. We are to full management support, and as you see, Agile practices and adoption to deliver good code. And because of our following of Agile practices and overall experience in software discipline of going over to 3 decades, we really help our clients reduce the risk of software development and delivery. We are able to ask the tough questions up front and really help the team deliver consistently. And not only deliver, reduce the risk through that experience, but also because of our dual shore operation, we have a development center in India and a small team on the US side. So we are able to bring in a front end and a client-facing team in the US time zone and a development team in the India, still provide a 50% cost advantage. And for most of our clients who feel a need to have some sense of control and flexibility over their offshore team, we provide a flexibility option, build, operate, transfer, commonly known option, where they can convert the team that they are working with us into their own captive operation whenever they feel a need for it. So that's SynerZip in a nutshell. And the next page, as it refreshes on your screen, will show the glimpse of some of our clients, and I won't go through any of them, but just reiterate the point that almost all our clients are small to mid-sized companies because that's where we feel we have highest value to add. So with that, let me now pause here and take questions. So in the interest of time, Don, I want to take just a few questions that are burning and significant ones. So first one is you illustrated various testing approaches, unit testing, TDD, and BDD. Now, can you guide people who are struggling and with adoption of TDD as to what kind of a training that a typical development team, a good, well-performing development team would need, and what kind of a learning curve we are talking for the team to actually become proficient to adopt TDD actually?
Yeah, well, hopefully one of the themes that you got out of that everybody got out of the presentation was it's more of a journey. I mean, it took me that whole journey. I said we're going through unit testing and truly understanding all and feeling, these different problems really I had with testing early on. Like I knew it was the results were good once I had them in place, but getting there was pretty hard. And going down that journey took time. For me, honestly, by the time I really got into that BDD style, I'm looking at, it was probably like a good 2-year turnaround of development before I truly got it. Now, I learned the hard way many, many times. And I think somehow finding a way to get them immersed and paired up with somebody that does this all the time. We don't, like, my role is in the training field, but we don't see training as always just classroom stuff and go to some 1-hour webinar like this. I mean, hopefully this will read some thought, get you thinking around these things, but you have to experience it, like I did, and I tried to walk you through in this presentation. So maybe pairing up with people, actually doing it, going through the motions with it. I think that's the key. Given that, what I've seen with our clients, and with clients that are actually doing this day in and day out, I would say more about 6 months to a year at that point where they get it and they can't develop any other way. Like I'm at a point now where it's very, very hard for me to build something, and I just this week I was doing a training class and I had to build a solution that was all messed up and didn't have any tests so that they could apply it. And I found it extremely hard to build something without first speccing it out in a test. And that's where we want to get everybody to as well, if you really want to benefit from the whole TDD, BDD feel. I hope that answered the question.
Yeah, that did. So in addition to what you just said, is there any kind of a seminal book or two that you would recommend for the attendees today on TDD and BDD?
So the main book that I read that kind of jibes the most with my style and the way I like to do it was one. It was called Test Driven, and it's Lassie Kosola, I think his name is. I may have gotten it a little bit wrong, but it's called Test Driven, and that kind of walks you through the whole idea from acceptance tests, from requirements, and then how you bring those into tests. But you'll find that nowadays there's most code books now have to deal with test-driven development. Another really good one is Writing Effective Legacy Code by Michael Feathers. That book is, I mean, at first glance you think it's, well, I'm writing legacy code. It seems old, but what it truly is a TDD book. But it deals with something that most of us have to struggle with. On most projects now, you're not doing greenfield development. You're working on code right now that is a mess, and you don't have the luxury of going in and doing things the way you want. So it takes the approach of, all right, you're presented with all this code and this mess, and you want to have some tests, but where do you even start? So, and he defines legacy code as code without tests because you're afraid to touch it. Only a few people know it, and that's a great book too. If you haven't read, that's a must-read, specific to legacy code. But anyone that does TDD should read that book.
Excellent. Okay, let's take one more question, given the time barrier we have, though, which is if you have a team and you have a mix of, it's a relatively large team, and some developers are at a certain stage of their proficiency in TDD, and some are not at all there. I mean, how do you manage a group, and can you have a software project where some parts of it is done in a very buttoned-up TDD manner, and some parts of it not at all? Any advice and guidance on that?
Yeah, I mean, in a situation like that, I'd ultimately like to try to pair up the people that do with people that don't, that kind of a situation. Teams should also, it really helps if the team themselves, to really be a good team, should agree on their style. I mean, on whether they write tests or not, and if they do, at what percentage. They should have a unanimous decision of what's and there might be some negotiation between the people that aren't into it and the people that are, but that's important to get to that stage. And you can put in tools and stuff that check your code coverage or whatever, but the team has to agree before doing something like that. So yeah, pairing them up, and I mean, it's okay if not everything has tests. I just know that if I'm working on something, I'm going to want a test before it. And if I'm going to work on something you've done and there are no tests, well, I'm going to try to figure out what you did first by writing a test. The characterization test is what Michael Feathers calls it in his book, so I can understand it, and then I'm going to add tests around that. Now, if we don't have 100%, that's okay. It's not going to affect me. And if you don't have tests for code that nobody's ever going to touch again, then that's okay too. We're not going to actually, if we're not ever going to maintain it, then there's no need for tests around that code. So that's just the approach I take as somebody going often into teams that don't write tests, or some do and some don't. I mean, it's not going to change the way I develop as well. Okay.
All right, one just follow-up question from the book titles. I think people couldn't hear the first one. The second one, I think I typed it in. It is Writing Effective Legacy Tests by Michael Feathers. The first one was test-driven, and who was the author?
Lasse Koskela, and I just picked it up. I found it here. So it's Lasse, L-A-S-S-E, and Koskela, K-O-S-K-E-L-A. It's a practical TDD and acceptance TDD. It's for Java developers, it says, but I think the Java piece is secondary to.
The title though is test. The book
test-driven. Yeah, it's a Manning book.
Okay, all right. So I'll send to all. Okay, thank you very much, Don, for joining the webinar and illustrating these in a very kind of a tangible and a real practitioner view way, which is very valuable for our audience. And all of you who attended, thank you for attending the last webinar of 2010. And we are geared up for next year and already have planned a very good webinar for January. So stay tuned for that invitation. And in the meantime, have happy holidays and great Christmas, and we'll see you in January. Thank you all.
Thank you.